Dektak 3ST. The surface profiler. Could be used for measuring step heights up to 6-inch wafers you can handle. The profiler has a motorized stage for the stage XY moments, X-axis and Y-axis moments. And the stage can be driven in two modes, either slow or fast. And there is a knob here, focusing knob, at which we can raise and lower the tower. And there's the tiny knob here is for the lamp intensity adjustment. Soon after boot up, the system prompts with a question to set the video source. It has to be set a composite, and then it is a composite and NTSC standard. Just click OK. If the stage was not initialized, the stage will move to the initialization location. Right now the stage is already initialized. The software is, the application program is very simple. You can select a scan routine, and here in the scan routine you can select various parameters, the scan length and the scan speed. You can select scan length in micrometers, and speed it can be selected low, medium or high. And for better resolution can be selected either high data resolution or medium. The stylus force is also adjustable. Right now it is selected 30 milligrams. And the profile, depending on the step height profile, either you can select a step up or a step down or both. And the display parameters, we can do software leveling by selecting the auto leveling, and the width of cursor, which will be a band, can be selected in microns. I'm selecting as 20 microns. And the display range, we can select auto, or we can select the limit, upper and lower limits. For leveling, the cursor positioning is to be selected. Right now the cursor is selected. The reference cursor, which is OR cursor, is at 100 micrometers, and the measurement cursor will be at 1900 micrometers. And this is important for the leveling. There are also other parameters which can be selected depending on the requirements, such as the short pass filter or long pass filter, and the smoothing parameters. And also some analytical functions can be added to the program, such as roughness and step height. We can also select peak, valley. All these different values will be computed and will be displayed after the scan is complete. Now, and then we have to select the reference and measurement cursor location to be approximately in the center of the the profile zone. We can run a single scan, or we can run from a program. There are three different modes of video display: video only, graphics, and video and graphic. At any point of time, to check where the stylus is landing on the sample, stylus up and down buttons can be used. And there are print options, and then setup and calibration is for calibrating the system if necessary, and stylus reticle alignment is to be done only when the camera position is changed. And we can assign a print report. If there is no OmniPrint 426 available with this system, so any external printer can be hooked up to the 25-pin line printer port. And for maintenance purpose, the diagnostic screen also exists. We can initialize a stage, and the other static and standard scan modes are available. So as soon as we hit run, the stylus will be initialized and the tower will start coming down. We can see the stylus is slowly coming down to touch the sample. This is a standard with a step height about 9,000 angstroms. You can see the scanning happening right now. So you can see this very fine vibrations here, which is caused due to my hand while it is scanning. These are the parameters I have selected and which are displayed here. So starting one more scan. If this surface profiler is mounted on a vibration isolation table, the performance will improve a lot, especially when very thin films or step heights are to be measured. Even the computer can be mounted on a separate table to isolate the vibration generated by the computer cooling fans. That would help. So I am scanning at medium speed. When a low speed is selected, it will take a little longer time. So I'm going to position the measure cursor approximately in the middle and do the analysis. And so right now the reference to measurement cursor, the step height is about 9,545 angstroms, which is about the correct value. Now to get more accurate measurements, we can move the cursors very closer to the step, and then we we can select a smaller window and replot it. So now we see we are about at 100 angstroms of the reference cursor is positioned from the step, and the measurement cursor is, we can move it. Closer to the step height. And in the plot menu, there are replot, level, 0, and various different boundaries can be set to merit accurate measurements. And we can select bands or clear the bands at any point of time, and filtering can be adjusted. So I'm going to change the standard to a smaller step height. This is a standard which is about 1000 angstroms. So I'm going to use the stylus down button to lower the stage. The stylus is shipped with a shield in front of it, and this shield should never be removed because it's, even while profiling, the shield has to be in place. Now let's see the display. So that's the stylus tip there. Now I'm going to move the stylus up and show how the stage could be moved.
Maybe I can start that, and then maybe I can grab this from you today, or spray it out. You think you might fix it by next week?
So I'm zooming in and zooming out
Well,
the camera input by pulling or pushing this knob. So this knob, we pull it out, push it in to zoom in, and then we always select an area where it is relatively cleaner. So I'm going to do the stylus up, and let us run a single scan here. This is a used standard. You can see some dirt on the scan standard. These standards are for in-house testing, and we will not include these standards with the machine. Various Dektak standards are available for sale from us and from other suppliers. A good standard will be available with the VLSI standards. So this shows that there are a lot of vibrations in the system here due to the computer. So let's see the approximate measurement of this.
all right, so as soon as you get it set, you can stop
So the cursor speed can be reduced by clicking on F here. I'm going to select the scan area and replot it. So I said this is 1,000 angstrom standard, and it is measuring at 1,083. That could be attributed to the vibrations in the system. I have not mounted it on a vibration isolation table, nor the computer is on a different table. Yep, we are getting closer to the battery. Anytime if we want to access the stage, to remove it for cleaning, raise the focus knob clockwise and the tower goes up, and once it is all the way up, using a flat plate screwdriver, there is a screw here which can be accessed, and now the stage is unlocked and I can move it out. So always remember there's a cable here attached for the stage drive mechanism, and there is a drive gear tooth arm here. This drive arm should go through this slot here and should be engaged to the arm by rotating the screw counterclockwise. Clockwise to take the stage out, counterclockwise to lock it in. So I'm going to install it and connect the stage drive. And then engage the drive mechanism. So now the stage is ready for operation. So I have just, in the diagnostics, I have initialized the stage. But the system will be shipped with the stage out of the profiler, and there is a glass slab here which will be covered with tissues, and care should be taken not to drop anything on the glass slab. I'm demonstrating the alignment of the reticle here. So position a standard on the stage and press stylus down button. And then in the setup we have stylus reticle menu where you select align, right? And then once you say align, the tower will start coming down, and once the tower touches the sample, or the stylus tip touches the sample, now we are positioning the cursor where actually the stylus touches the sample, which is important so that we can position the scan location, the initial scan location. So once you position it and double click it, the system will say, do you wish to update the stylus reticle? You select yes, and the stylus goes up. And then this crosshair, position it exactly at the intersection of the red grid, and double click with the right button on the mouse, and you are now the green crosshair and the red crosshair are almost aligned. This is a serial mouse, and this pad is very essential for this mouse to operate. Without this pad with grid pattern, the mouse won't work. And the mouse is connected to the 9-pin serial port on the computer. This application to work, only this mouse is to be used on this machine. This computer is a customized system with a hardware PCB installed to drive the stylus profiler here, and no attempt should be made to upgrade the software or connect a USB mouse or any other external hardware other than this. Can you connect a standard printer though? And once you connect the printer and load the Windows drivers for it, you should be able to print the data on the printer.